Okay, before that, we looked at exceptions, and then we looked at how do we. The important things to remember in exception is that the stack trace and where it is coming from and what does it mean, and then how do you sort of handle those exceptions using try and except block. And there are specific exceptions that you can handle, and also there is like else and finally keywords which are optional, and that is about exceptions. And then yesterday we looked at modules and packages. Modules are nothing but files. File, what does any file contain? It will contain the like Python variables, functions, classes, and then when you put these modules together, it becomes a package. So there is a way to import these packages and libraries. Yesterday we looked at some syntax. So that is about yesterday's class. So today we'll look at some of the like lighter concepts. Like these are not most important concepts, but we need to get used to these concepts. So one is called as list comprehensions. This is a small concept, and we'll look at some more small concepts today. One is list called as list comprehension, and what does comprehension mean in general? I'll show you. For example, this is an example. So if you look at this, let us try to understand what this line of code is doing. And if we had to write without this format, or without this format is called list comprehension, how the code would look like. Okay, so we are trying to calculate the squares of numbers from say 0 to 10, excluding the 10. Okay, 10 numbers. So if you had to write your own program without this, it would look like this. Say I'll just write squares is equal to, I'll instantiate an empty list. So, and then I'll write a for loop, which is for say x in range. And then I will be writing something like y is equal to x into x. So number multiplied by itself, it's a square. So, and then I'll take this y and then add it to squares, which is appending a number, which we looked at. And then I will print this. So this is exactly same as this. So let us try to understand the syntax. Basic syntax is like this. Let me annotate and show it. So what is happening and what is the advantage of doing this? Let us try to learn. So this is a function where, this is a for loop where we try to calculate the squares, and we are kind of adding all the squares into this bucket. So this is a list. So there are two variables that is involved here. One is this list itself, and another is like you can see that there is one more variable which we are trying to use and then add into this. If you look at this, those two things are not defined. If you just look at that, so how does this work, and how is this related to this, and what is the difference? One difference is this looks cleaner, so that is the advantage. And this, once you get used to this sort of line of code, you'll see that it's easy to read the code, because here you can see that there is 5 lines of code, and here it's just 2 lines of code. So if you forget about print, it's like 4 versus 1 line. So it's easy to read, like squares is equal to something, okay, x some operation, and then there is a loop. And then out of this loop, we are creating a list on the fly. And So one is readability, and second thing is you can see that we are using a function here, append. Append is a function which is defined inside the inbuilt data type called as list, right? So yesterday we like one of the classes we looked at objects. In objects you have functions and then you have attributes. So one of the functions inside by default is called as append. And yesterday, day before yesterday, we looked at exceptions, and how exception occur is um, when it throws a traceback, we looked at traceback of the functions. So functions get onto the top of the stack and then gets removed once that scope is gone or function is done with its execution. So what happens with this append is that, so you will have a stack and then there is append gets called in first zeroth iteration and then goes out of the stack, and again um, append comes second for the second time, which is zeroth iteration, first iteration, and so on. So until 10th iteration, which is like 0 to 9. So we're adding the append to the top of the stack and then we're removing that. So this overhead is not there here. So which means this is also readability and lines of code. And third is efficiency. So there would be some places in program where you want to say here, or you want, so this is just 10 numbers. What if you had to calculate squares of say um, 10 million numbers? So if you actually calculate the time taken to add this function onto the stack and removing this, so this becomes an overhead. So in such cases, the most efficient way to do is this. So this is called list comprehension. It's like comprehensive, like we are reducing the code and it's readable. So that is why it's called as like comprehensive. So that is about list comprehension. So and we are not creating any additional variables, but internally it returns makes a list and gives it out. But in terms of memory, it's the same thing. But in terms of efficiency, it's a lot better than this traditional for loop. So when to use comprehension and when not to use is like if you have complicated code within the for loop, like if you have 10 lines here, so then don't go for it. So because it affects the readability for the next programmer or yourself when you read it in for the second time and so on. So if it is smaller, like it's like a when you look at the code and it looks like bite of small place where you can optimize, use it, but do not overuse it and make it complicated by yourself. Of course, you don't need to remember the syntax. So just remember this syntax. You can put for loop in one line, for loop, and then same instruction here, and then you can just simply print, take that output and then print it. Yeah. So the format is simply initialize an empty list, put the for loop here. You know the syntax of for loop already. So the element, and then say you can also have say some sort of list, or you can also use range if you want to generate numbers. So you can, maybe you have a list where uh, you have some strings inside that, like names of uh, names inside that list of names. So you can simply send that names here, and then probably you want to um, add or capitalize all the names. You can simply take this I and do say to upper. So there is a string function which will do that. So this is how the syntax looks like. So whenever you look at this code, Remember that it's just a traditional loop written in an efficient way. And it's like, in terms of, uh, some uh, some people look at code like a poetry. Like it should look clean and neat, and uh, it should not give out information which is, um, you which is sort of takes more uh, willpower to get into the code and read. So it should be easy to understand. So in such cases, to make it make the code look nice and neat, this is very good efficiency, and then how it looks. Okay. So that's about list comprehension. In fact, you can use this comprehensions for, so this is one more example where, you can use it for dictionaries as well. Same thing, same syntax, but when you put the flower brackets here, Python understands that, okay, this is uh, um, either a dictionary comprehension or a set comprehension, because flower bracket is used both for both sets and dictionary. So when you have key and value sort of a expression, it knows that, okay, I need to create a dictionary. So when you do not have key and value, just like the same thing we did it in list. So if you just replace that square brackets to flower brackets, it becomes square set comprehensions. So same thing. So difference between set and list we have seen already. It is very good for uh, searching purposes. So in list, if you have to find something, you will have to like iterate from the beginning till the end. But in set, it's not like that. So if you have like 2 million numbers, you can directly go and fetch the element that you are searching. If it's not there, it will get out of the operation. So that searching times, or in computer science, it is denoted as, like, in list, if you are searching from first position to like 2 million, imagine there are 2 million items, and if you want to search some item, say 44444, some element in that, so we'll have to start from 1, and it goes from here, and then when it finds this number, it gives it tells that, okay, I found this number. So if it's 2 millionth element, you will have to walk like 2 million steps here. If there is no number at all, you will have to walk 2 million steps and find out, okay, that number is not there, and exit the loop. But in set, it doesn't work like that. If you want to search this particular number in that list of numbers in the set, so it will, there is a way in mathematics, it's called hashing, that you take this number, say that 444444, and then you can simply uh, send that number into a function. This function is called as hashing function, and then this calculates some number, and this number is somehow directly tied to the memory location. So that is how the hashing function works, and it is easy for searching. Now we are not searching from first position till 2 millionth position. We are doing some sort of smart operation, and we're trying to directly find out the memory location. So going into a memory location is easy, right? Because in list you can simply do how do you go into, say, third element in list? So if I have my list, the the third element would be like, first element would be 0, first and second. So you'll just get this. So this is direct memory access. Like you can go to the second third element directly. So similarly, so this operation results in same operation. So we would find the index and then directly get that particular memory. So that is how sets are different from list. So in comprehensions, when you use list, this is helpful for creating some sort of lookup something. For example, if you have say 1 million IP addresses, and every time there is an IP, and probably all these IP addresses belong to your company or your subnets. And then you sort of want to find out whether the IP address is there, it's mine or somebody else's. And then you have some rule saying that if it's not there, reject the packets or do not allow any connections or something like that. So in such cases, put that in a set, and then search operation will be easier. So that is about set comprehension. So let me delete this. Uh, and dictionary comprehension, same exact syntax, but you'll just have one more element, which is key and value. So that is about dictionary comprehensions. And also you can add some conditions within this, which looks like this. For example, dictionary comprehension is this is key and this is value. So you can, same syntax like in set, we have for loop. So some for loop, and then instead of one element, here we are dealing with two elements. So here it's x into x squared. So once it sees the colon here, it knows that, okay, this is a dictionary and this is how the output looks like. So if you put it in one line, like line by line, it would look like 0, 0, 1, 2, 4, and 4, 16, like this. So now this becomes your lookup table. So if you have a list of, say, imagine these are roll numbers and a roll number versus, say, name. If you want to search for a particular marks of a certain student, say if you have an alumni database, probably thousands of people have passed out from the school, and that roll number will directly give us that particular name easily. So because it is dictionaries are optimized for searching because it has key and value pair, right? So yeah, we looked at example in the beginning class for in a railway station. When you go to a clock room, you get a key, right? It's a similar thing. Okay, that is about dictionary comprehension. And then you can also add some simple if conditions. You can add complicated ones, but don't make it unnecessarily complicated. Here we are trying to calculate if x is even number, only then calculate the square. So we looked at this example in the beginning of our class. So we wrote a for loop and then we wrote a condition, right? Exactly same thing. So, but in a much more, we can say, sweet format. It's because it's readable and it is efficient. So that is about list comprehension. You need to read or you need to look at code which has a lot of this, and take this Jupyter notebook and then try to translate this to the traditional for loops, and you will understand. So that is a small concept related to comprehensions. Okay, you can try. Any questions here? Like, does it look better than traditional for loop, or is it confusing? What do you think?
No, it is better. It is better than for loop.
Yeah, correct. Yeah. Okay, so that is about a little bit about comprehensions, and let us look at one more um, such small concept. It is called as a generator. So what is a generator and why we need to use this is a question. So I'll just give an example. Let me open a new file. Let me just annotate so that I can write. Okay. So so far in list operation, so we used to write for loop, and then say take that particular say list or any iterable uh, for x in some iterable. Let us call this iterable. And it could be list, it could be dictionary, it could be set, and so on. So when we do this operation, what happens is sometimes these list or iterables are calculated in the sense, for example, just now we saw how do we generate list of square numbers, right? So there is just like x into x and then some for loop, and we used range sum 10, and then we copied this into a variable. And now if I want to iterate through all these squares, I would do a similar thing. So let me write a traditional loop for s in squares, and then I will write my operation here. So what is happening here is we have calculated the squares of numbers, and we created a list, and I'm sending this list into this operation. So if you look at this, let us just consider this is a list of characters, A, B, C, D, and so on. And let us assume that each character is just 1 byte, and there are 26 characters, which is 26 byte. So A to Z. So I have a list which contains, say, list of this A to Z alphabets. So when I use it here, so I'm consuming, say, 26 bytes, and then I'm operating here. So when you trigger a process, when you trigger that particular program, what happens is it spawns up the the process, and then you'll see something like in your memory, you will have this 26 byte sitting here all the time when you are, until you sort of go out of that context where that particular list of alphabets goes out of the scope, and it gets deleted by the garbage collector. Okay. So this is how the programs uh, deal with the memory. Okay. So 26 byte, just remember that 26 byte is sitting inside the memory. So imagine there is a similar operation. Imagine there is a um, file which is about, say, um, 1 terabyte. Okay. So this is just 26 bytes. It's nothing. 26 bytes is like one SMS or one text that we send on WhatsApp. Okay. Probably it's even bigger than that. So if you have, um, say, let's take 1 terabyte file. You want to read this 1 terabyte file. So you cannot read. You cannot use, if you have to deal with, say, write a function where I will write for in line, um, for line in lines. Okay. So these lines, probably I have written a code before saying that open that file, some open, fd is file descriptor is equal to that open, and then I might have used fd dot read lines or read. So when I do this, I collect this in a list which is called as lines. Lines is equal to fd read lines. So if it's a small file, right? So probably 1 MB or something like that, you can, it doesn't matter at all. So imagine now we are dealing with 1 terabyte file, but I do not have a way to, read it, simply line by line. And we are putting, if you're trying to read 1 terabyte line, use 1 terabyte file using this read lines, we are putting heavy operation on operating system to take that, split that 1 terabyte into small chunks, depending on the memory available. It will load chunk by chunk, and finally it will, give a list. And sometimes your program won't support and it will die. It will say that there is no enough memory and you'll get an exception. So how do you deal with such problems? Like this is one example. Another interesting example I'll show you. So you are dealing with a file which is say which is coming from the network. You're downloading something and you have network. So just imagine that it's a network and your PC is here and you're downloading a file. And you roughly know the size of the file, but you don't get the entire file in one shot if it's big. It sort of gets streamed. For example, in Zoom, um, we do not know the end of this file, right? Because I'm talking and we are meeting, but until we press that end, it doesn't end. So these things are called as streaming. For example, Netflix is a streaming and so on. So how do you deal with such things? So this is something which we can think of stream of data. So now going back to the previous example, so 1 TB file, I can read line by line with something called as generators. So what these generators do is just for to understand the concept. So we generated squares of numbers, right? So x square, and we had that list. So imagine that there are 1 million numbers. So, and then I'm processing here for x in list of this x square, which is like list of squares. And then I do not want to calculate these squares because these squares it's not like list of names or it's not like something which is like static. So I can actually generate this particular element object. So how do I make sure that when a program runs, I do not want complete 1 MB file or 1 MB of resource to be used. I just want that particular on the fly, I would generate this square of numbers and send it to this for loop. So by doing this, what do I gain? I gain memory efficiency. Memory efficiency. So I'm not using the entire um, data type or the list or whatever I'm trying to read. So if it's a file which I'm dealing with, I'm not taking the entire file and loading it. I'm on the fly, I'm calculating some line of the code and then I'm uh, reading it. Okay. So this is how the generator comes into picture in order to generate this particular values or take that particular, instead of doing everything in one shot, you do step by step. So you on the fly you generate and send it to the for loop. This action is called as generation. So this uh, how do we realize that in code is using generators? I'll just show you what how it looks like. So in this example, we have a generator function. So how is it different uh, than the normal function is there is a keyword called as yield. So all the functions so far, what we have seen is it does something and it doesn't remember anything. So it's like you call a function. Once you are done with that, that function doesn't remember uh, the variables inside it or the operation that where it ended. So it's like putting it onto the stack and then just removing it. So in this particular generators concept, we have a way to store some variable inside that function and we halt that function for until we get the entire thing done. So this is a function. It counts up to say any number that we provide max, and yeah, do not use for example, it's better to use max number because max is well, I think there is a inbuilt function, but yeah, for now let us consider that this is just a variable, and it sort of initializes count is equal to 1, and then there is while loop, and then in fact you can do it in for loop as well, but yeah, this in this example we're just using while loop, and until this count hits max, so it will increment the number. Okay, so without this particular yield, it, okay, what is happening here is, so you can also see that there is no return statement here, and when this line number 8, when it completes the execution, it sort of gets, without anything, it gets none, right? So by default all the functions return none. So, and then if you try to iterate over that none, you'll get this error. None type is not iterable, because we are actually trying to find out whether no, anything that you put needs to be iterable, like list, dictionary, and so on. So how is this different? What does yield give you is, it makes that as an iterator. So that particular, it makes some sort of a object which you can iterate. And once you have that iteration, so it doesn't have the end pointer, like if you provide the list, we know that the ending is the size of the list, right? It doesn't know. So for loop supports this sort of iteration. So you know that, okay, there is an iteration and end will be coming soon based on this function. So when you do this yield, it just gives us one number, say for example count. Let me annotate so that we can understand what's happening inside this. So if you do not have this, and say return some number, you'll return, but you won't be able to iterate, because you cannot iterate with just one integer. You need to have list of integers. So if you had to do it traditionally, you will have to like write a list comprehension, or write your own list and collect all the numbers and then iterate through it. Now the difference is, I have yield where this function gets loaded onto the stack, count up to, and it sort of pauses here. So it gives in the first iteration here, so it calls 1, it it is initialized to 1, and then it looks at this number, is it lesser than max, because we have provided 5 as an input to this max, and it remembers, okay, it is not greater than max, so it will just increment this. Sorry, it will just come here and yield that count. It will just return this count. It is not the normal return. It is it returns an object which we call as generator, and it has the value 1. And that is how this for loop is able to print 1. And in our usual function without this yield, what will happen is, this particular stack, I have put this particular stack frame, it will go out of scope. But since we are using this particular keyword called as yield, it sort of remembers that, okay, I'm halting here and I am waiting for this thing to be executed. So once it finishes iteration, so iteration is nothing but like, you have an object and then you have a pointer, instruction pointer. Once this, you kind of move to the next element. So for by default, every data type has our inbuilt function called as next, double underscore next. So if you look at dir of any list or any iterable, you'll have this. So for will automatically invoke this next. So this yield will silently put some operation called as next, and then When it calls next, again this function is invoked. So when this is invoked again, so now we have it has stopped here previously, and it will move to next line of execution. It will increment the number and goes to the call again. The important thing to remember is the count is not getting a reset because we are not taking this out of the stack. So count is still, it's sort of in if you think about in from C++ or Java point of view, you can think of it as like a static variable. So in your process map, so it will go to some sort of memory which it doesn't, we do not clear off once the function call is done. So from this particular memory, we sort of keep that particular variable where, remember that it's like a static variable in C and sorry, C++. Yeah, C is, even in C we have it. C++ and Java. So that is how this yield comes into picture. So whenever you see yield, just remember that it's a generator. So where do you use this is what we discussed earlier. This is how we sort of realize in code. And let us try to print uh, what it does. Okay. So the print the say counter here. I am going to print counter and I'm going to okay, run it. So line number 8 has given this particular uh, print. So it tells that it's a generator object. So remember that we haven't like finished this call. It's just the beginning of the call, and we have stopped it. And it has not iterated through all this. It has not executed this like say 5 times. So it has started executing and it returned or yielded. So there is a difference between return and yield. Return comes out of the function and then exits out of the function. But yield comes out of the function and continues from wherever it stopped. So yield is similar to return, but there is a retention in the memory. So this count is retained. The variables are retained. So you can see that it's a generator object. So let us see inside this what are the things that it provides. So you can see that it's an object. We saw that it's a generator object, and what are the items that we get out of this generator? Like there is class, del, greater than format, and so on. You can see that this is something which is of our interest. There is a next. So this next is the one which uh, for loop calls this next. For loop is programmed to call next in every iterable, whether it's list or it's a set or it's a dictionary key and value. So any iterable will have next. The reason that you actually, in fact, you don't need a for loop to jump from one point to another point. You can simply use say that say list, and then you can simply use dot double underscore next to get to the next element. So you don't need a for loop. So basically what we're doing is we are in the beginning, we when we are studying about data types, we learned how to count, right? So like we broke the piggy box, and then we collected the coins, and then we tried to count the coins blindfolded. So how do we go to the next element? By using our finger, right? So when I move the coin, so that moving is uh, actually simulated using this function. And for loop is made aware of this next function. So that is how for loop is able to like move step by step. Okay. So coming back to this generator code, this yield generates an object which looks similar to an iterator. So any object, if it has next, it's an iterator. That means there is something next, you can get that. So any questions how the now we are like we sort of did a reverse engineering for loop. Okay. So if you understand this function, next we understand for loop, how the for loop works and how this yield works, and how and hence why the generation does not take any more memory. So when you click on, sorry, when you call next, what happens is now I have sent 5 already. So it increases count to 1, like from 1 to 2, and then again goes back here, stops there, and again generates the generator object. Again, you'll have next. So when you click on next, again, it goes back to the where it stopped and it executes, comes back, and until this particular condition satisfies to be false, until this becomes false. So it'll just keep on doing this. Okay. So this is how the generator works. Remember the keyword yield. Okay. So now coming back to our example where we are trying to read 1 TB file, you can open the file and read line by line or read even character by character. You can use, there are functions inside the file. You can read, say, line by line. So, and then you can load it into memory and then use this yield to read the next line. So now we can easily operate with given memory and then carry forward our operation without using much of the memory. So that is about uh, generation. Okay, this is like quite basic concept. It's like say if you walk into say college for admission, the clerk who is filling your, say, verifying your application, he doesn't know how big is the queue. So he's like takes the application, looks at it, and then just moves it, and you just move from out of the queue, and some new person comes and he does the same thing. So he is not taking all the application in one shot and doing it, which is like a typical for loop that we saw. Or he can do this one by one so that he can commit to only how much he can do, right? For example, if there are 100 people and he can do only within his lunch time, like 2 hours, probably he can finish only 50 people. Like other 50 is like just waiting, right? So he doesn't have to take all of 100 applications and start doing it, because it's like his table, you can imagine it's like a RAM, and it's just simply sitting there and doing nothing. Okay. So it is wasting his resource. So that is how you can think about this yield function. So it comes, does some operation, we return in a way that we retain the state. So that is, so this is, you can relate to return. It's a return with special abilities. Okay. So that is about generator. And if you have,
Digant, is
yeah,
it okay to say whenever we have to use a for loop, if it's a small list, it's okay.
yeah,
If the list is big,
yeah.
and if we have to use a for loop, then we have to think about using generators.
Right. Yeah. When you
Okay.
review the code, or when you, sometimes what happens is, I think not sometimes, most of the times, when developer uh, doesn't know the entire picture, usually happens with the junior folks. Like it's difficult to get. It's not their problem. It's difficult to get the big picture. So somebody might say use a, an SQL and get a list of some data, say students, and then he operates on that and then he finishes the work. So he might have written code in such a way that the traditional for loop and without generators or anything like that. And when it actually goes to the next level of testing, so their SQL is different. Like testers SQL is different. It is simulating the real world. So maybe that is like too huge file, and his query may be not optimized to read line by line. He can be like reading everything in one shot, so you cannot load it into memory. So in such cases, like you need to be while reviewing the code, look at, okay, how big is the data? Not just look at the code, look at what is the input, what is the size of the input, and then proceed further.
So is it like a best practice then to always use a yield
In
wherever we
fact,
use?
yeah, so that's a good question. So in fact, this was discussed, in various Python forums, and then in one, so we are already using it without our knowledge. We have used something called as a range. Okay, so if you want to generate list of a range, right, I can simply do this. X and type of X. If you look at this, X and type X. So we haven't generated anything here. So it has optimized, Python has already optimized that. So let us try to look at what X or range looks like. So this particular thing is actually a generator. So it doesn't actually generate all the 100 numbers in one shot. When we use it in a for loop, like for X in a range, say many numbers, and then print X. In fact, we are not generating this many numbers at all. A range is actually a generator. So that is why when you try to print range 100, you don't see all the numbers, 100 numbers. So like 0 to 99. So it is already, so I think in until 2.7, the range was returning a list where it was memory inefficient. And then they made it default for such operation. Yeah, it is good to make it default, but for small cases, yeah, uh, you know, um, don't make it harder for like developers, and don't take it hard on yourself to optimize everything. But yeah, by practice, you should have always an idea that, okay, it's not just the code, there is also like memory involved. So that is why I started the lesson with uh, RAM and how things work, because it's like nowadays programmers, I sort of train the freshers and interns. So when they come with a background with Python or Java, so they have never dealt with memory, because if you have learned during our college days, we used to learn um, assembly level program languages, and then there was one subject, electronic subjects, and then we used to learn C, and then do all this higher level languages. Like probably in final year, we will learn a little bit about Java. So it sort of wires your brain that, okay, there is a chip that we are dealing with. Most of the times I say I'm typing on laptop, I do not think about the resources at all, because it's available at a cheaper cost now. But when you actually come to industry, you have the same mindset. You are not thinking about the memory, and then you are like littering the code with so many uh, practices where the memory is involved, and it goes out of memory sometimes when you are trying to do that. So just keep that in your mind, that we are dealing with the resources, and the resources needs to be like, it needs to be optimally used. So if you use, say, if you are generating, say, just to give this cloud sort of example. So if you're generating Amazon AWS cloud nodes, for example, some Lambda or anything like that. So you're instantiating servers whenever you need. So imagine that you are using a list, and then you're initializing all of them, and then making a list, and then using it. And probably you may not be using like half of them. And Amazon bills you like probably hourly or something like that.
You still
So,
get charged.
yeah. So you don't want to be in such a situation. So especially even the DevOps engineers who are starting out do this sort of a mistake, and your Amazon AWS bill goes high and things like that. Not just using the for loop or probably in a script. So we initialize which we don't require. So keep that in mind. Like generator has advantages. So whenever you want, use you take that, use it, get on with next section of the code. So that is about generators. So these are like two interesting concepts. Yeah, in fact, you can do without generators and list comprehensions, but these are like good to know and makes you a better programmer or an engineer. So even if you are not coding, just keep that in mind, like how things needs to be optimized.
Thank you. I had to drop off. Thank you.
Yeah, sure. Yeah, we are at 8 o'clock. Any questions? Anything? Or if you want to, get in touch one-on-one, you can do it now. So that's about today's lessons, list comprehensions and